All right, we're going to continue our explanation of the exponent rules, or exponents rule. This is, we'll call this part 2. All right, we're going to talk about what happens when we have a base that has more than one thing in it. We have 4 times 3 to the second. Now, our order of operations would say we can do inside the parentheses first. That should be the same as 12 to the second. But they're not always numbers in there. Sometimes they're variables. Sometimes they're other things. And our exponent rules are always true. So let's think about what that would mean. 4 times 3 to the second would mean the same as 4 times 3 times 4 times 3. Well, if we do that out, we have 4 to the second, we have 2 4s, and 3 to the second, we have 2 3s. So we think about what those rules are meaning for us. 2 times 5 to the third would mean 2 times 5, 3 times 2 times 5, 2 times 5 would mean 2 to the third times 5 to the third. We have 3 2s, we have 3 5s. Guess what 1 times 6 to the fourth would end up being? Well, if I did that out, 1 times 6, 1 times 6, 1 times 6, 1 times 6, I would have 1 4 times and 6 4 times. Our rule here is that that exponent applies to everything inside the parenthesis. It's kind of like, and the word I hear students use sometimes is, it's kind of like a distributive property. It's not really distributing. Distributing is across addition or subtraction. I'm going to use the word applies. That exponent applies to everything inside the parentheses. It's kind of like distribution. It's not exactly the same. It applies to everything inside the parentheses. So if I think of that algebraic rule, if I have 2 things or multiple things inside parentheses, all raised to the same exponent, a times b to the m would be the same as a to the m times b to the m. One thing to note with these exponent rules, never inside those parentheses is there going to be an addition or subtraction. These exponent rules only apply to when things are multiplied or divided inside the parentheses. No adding, no subtracting needed. Everything is multiplied or divided. So again, the rule here, a times b raised to the m power, is that that exponent applies to each piece of the base. The base is whatever's in this parentheses. The base in this case indicated by the parentheses. If I asked you for a times b to the m, in that case, the exponent would only apply to the b. The exponent applies to what it's exactly next to. So we have to pay attention to grouping symbols here. In words, our rule will be just what I said, that the exponent applies to whatever it's directly next to. So I've written that as the exponent applies to everything in its base. There should be an E there, of course, meaning that we have to pay close attention to what the base is for our parentheses. All right, so we're going to build in this next rule. We're looking at a to the 0. What does a to the 0 mean? Well, let's think about what 5 to the third means. 5 to the third means 5 times 5 times 5. We got this down now. 5 to the second means we're taking one of those 5s away, right? We're really dividing by 5. 5 to the third is 125. 5 to the second, we're taking that 5 to the third and dividing by a 5, which would give us 5 times 5, which is 25. To go from there to 5 to the first, we're again dividing by a 5. That would give us 1 5. 25 divided by 5 is just 5. Again, dividing each one of these by 5. So what does that mean for the 0? Well, it means the same thing. We're taking that number and dividing it by 5. We're taking 5 to the first and dividing it by 5. 5 divided by 5 is 1. 5 to the 0 power should equal 1. Let's do that with 9 to the third. 9 to the third is 3 9s is 729. To get down to 9 to the second, we're going to divide that by one of those 9s, which would get us 9 times 9 is 81. To get down to 9 to the first, we would take that 81 and divide it by 9. 81 divided by 9 is 9. Now again, to get down to 9 to the 0 so that we have no 9s, our rules have to work here. And sometimes the only way exponent rules work is if we have everything clearly defined. If this 9 to the 0 is not 1, none of the other rules apply. 9 divided by 9 is 1, 9 to the 0 is 1. Our rule here is a to the 0 equals 1. No matter what, except there is one exception here. And that one exception is as long as a is not equal to 0. If the base is 0, 0 to the 0 is undefined. So that's one of those weird cases. For our purposes, the base will not be 0. So our rule, a to the 0 equals 1. Our written rule will be anything to the 0 power is equal to 1. Anything to the 0 power is equal to 1. I could give you the longest problem in the world. Big giant thing, all raised to the 0 power, it's equal to 1. I will do that on a test or a quiz. I will ask that question, and about 80% of you will get it correct. A couple of you will try really, really hard to figure out the answer. Anything to the 0 power is 1. I'm going to warn you ahead of time. We're going to pause here. These are two really important power rules. We got a few more to go. We're going to pause here. So make sure you have these first. I think we're on rule number 6 written down.